Hi, and thanks for joining me today here in my shop. Today is March 29th. I'm going to do my best to just lose myself in this radio for a while. You can come with me and we can hide away from what's happening in the world. So I didn't post a video yesterday. Yesterday's work in here, it went okay, but there's really nothing worth posting. So I'll tell you what happened. I came in quite intent on making this RTMA circuit connection to use on the antenna, between the antenna and my equipment. RTMA, Radio and Television Manufacturers Association. Radio and Television Manufacturers Association came up with a circuit? What? So things got a little more interesting here as I worked away on this. I have the circuit here. I built it. And then I realized that my inductor, this is the inductor, is 1/10 the size it's supposed to be. I then spent a long time trying to come up with some kind of inductor. Here's one. Well, I had like 15 coils out on my desk here, my bench, trying to figure out which one is going to be 20. And in the midst of all that going nowhere, I suddenly realized I think I have one. I think I have a professional one. Look at this box here. It says antenna simulator. It comes with this signal generator. I have a couple other similar boxes like this that came with it. This is a fixed attenuator. Antenna simulator. Inside this box is exactly this circuit with exactly the correct components inside this box. RTMA standard. This is called an antenna simulator. I'm having a lot of trouble naming this thing. Other documents call it a dummy antenna. What I would call this is an interface circuit between the radio and the test equipment. And I think that's the clearest thing. Calling it a dummy antenna is a dummy thing to do. There's nothing dummy antenna about it. It's an interface circuit. And I'm sorry if I'm talking away, and I think I've posted a video where I talked about this already, and maybe I haven't, so you might be a little clued out as to what is this all about. So let's take a look at a couple of documents here about this, and I'll talk a little more about it because I think in the end the story is very interesting and well worth knowing. So the first thing we're going to look at here is this alignment chart, and right at the top, here's that circuit, and there it is in capital letters: RTMA, Radio and Television Manufacturers Association. I'm pretty sure that's what that means. Dummy antenna? No, don't call it a dummy antenna. That's really misleading, very misleading in fact. So an interface circuit between the radio you're working on and the equipment you're trying to connect to it. And as I said earlier, but maybe didn't post, it's pretty clear to me that this thing's impedance is going to vary with frequency, and this is probably a very important factor in making certain critical measurements in a radio, such as putting in a certain signal level and then measuring the amount coming out of the speaker and then making calculations based on that, changing frequency and then repeating it, trying to graph all that. If you don't have a circuit like this, what you're actually graphing is variations in the effect of the test equipment on the radio. That's what you would be graphing. Now, we don't normally do stuff like that. I don't check the radio's ability to amplify a signal across the band. I don't do that kind of stuff, not directly anyway. But so an interesting thing now, we're going to flip. So let's take a look at some of the values here: a 200, a 400, a 20, and a 400. So 400 resistor, 400 capacitor. See those numbers? You got that in your head? Now we're going to try and look at the manual for my signal generator. But luckily here it is. So here we are, we're way in the middle of the manual for my big signal generator. It's like a 100-page manual. And in the middle of it, coupling the receiver under test. Lots of instructions here, and then look at this guy. Of course your eye has already found this. Look at the values. 200, 20, 400, and this is 400. I got it written here as 390. So this is exactly the same circuit. Now, is that a wild coincidence? It so happens the makers of this device happen to come up with the same circuitry, exactly the same circuitry. Is anybody who did this would always come up with exactly the same circuitry? No, I can't imagine that. The reason it's called an RTMA in capital letters is because it's a standard that's been put forward by the Radio and Television Manufacturers Association. Now, why would they do that? This seems like a very curious thing for the Radio and Television Manufacturers Association, which I imagine is pushing politicians all the time to come up with this. Why would they come up with this? So here's my guess on it, why this circuit would be even thought of. Because of all the problems occurring in shops like mine from not using this kind of circuit. So I can imagine back in the day, somebody hooking up their equipment, and goodness knows I'm guilty of this. The equipment disturbs the radio under test. You do the alignment in the disturbed state. You remove the equipment. You can't tell this has happened. You then check to see how it's working. If you think it's working good enough, that's it. But good enough is not where it could be. This is kind of where I've operated for years, in the good enough area. Good enough is good enough on these old radios, okay? But if you really want to try to get it to 100%, then you really have to think about all kinds of much smaller factors, including this thing, this RTMA. So to stabilize the situation in the industry, the Radio and Television Manufacturers Association came up with this circuit and said, hey, everybody use this thing, okay? And then when you all test the same thing in your shop, you'll get the same result. Whereas if you just hook up your equipment direct, you're going to get different results. We're not going to be able to talk about it, all that kind of stuff. Remember, 6 pillars to industrial society. Standardization is one of those 6 pillars. Standardization is the society we live in. Okay, I could go on about that, but I won't. So there we are. Now, that's what's in my little metal box. So here's how I'm using it. I'm taking my little metal box, I'm just inserting it in the line. There is no direction to it. It's the same this way and that. It doesn't make any difference. So now, theoretically now, the radio experiences something that it thinks is a regular wire antenna. So we can go ahead and do all the alignment stuff, remove this, put a regular wire antenna on it, and all the alignment work will be valid. In this radio, I've discovered a sensitivity of the local oscillator. It's not very, like stable might be the right word, but maybe not. It's not very fixed. And if you fool around with the antenna connections, you put different kinds of impedances on the antenna connection, the local oscillator shifts back and forth. This is a disaster for aligning this radio, and a lot of my work yesterday was trying to get around that. And I think I got there, but so what I did yesterday was I began, after fighting my way through all this stuff, I finally did the alignment on the 30 megahertz band. That was 20 minutes doing one band, moved to the next band, seemed to get it aligned, went back to the band number 4, and it was a megahertz out. How it got that way, I don't know. At that point, I just threw my hands up and said, that's enough for today, and I went back to watch more television news, which is probably a mistake. So I'm picking up today from that point. So I have this box discovered, I have it operating, I even have some of my equipment turned on now. The radio's ready to go. I've already done the alignment on the 30 megahertz band. The whole thing went sour, so we're going to start there again. So I think I'm probably in a strong starting position to do the alignment. Oh man, here we go. Just cross your fingers here. Okay, so screen's a little crowded here. Let me just take you for a quick tour. Obviously, here is my radio on camera, and the reason for that is so you can see where it's tuned. If you notice, the band spread is should be set to 50. Here, I was experimenting a bit. The reason it's set to 50 and not 0, and the radio instructions say 0, is in the 0 position there is no hope of aligning this radio, at least band 4, no hope of it. With it in the 50 position, there's a good chance I can align the top band where you see it, 15 megahertz, but again, still no hope at the other end. But we'll find out when I start doing this. So that's the reason you're looking at this, so you can see, you know, where things are tuned. Well, I can see it too, because the radio's in a bit of an awkward place. Let's put this, let's start. I'm going to set the radio. We're on band 4, 20 megahertz. Now I got to remember, if I go above 25 megahertz, I have to remember my SDR needs to be changed. And I'm going to check it right now. So you see the SDR in the other window. And I'm just going to stop it and check to make sure it's direct sampling Q branch. So that means the radio is ready to operate below 25 megahertz. If I want this to operate above 25 megahertz, I must remember to switch it to quadrature sampling. If I don't do that, and I go above 25 megahertz with this set to Q branch, the result is all kinds of funny, weird stuff on the screen, a little bit of which I showed you on one of my videos. So that was a fluky thing caused by me not remembering this fact about my SDR. So we are now set for below 25, so we'll stay below 25, which is why we're going to do some of the work at 20. Let's just pull this screen over here so 20 is on screen. Okay, so 20 megahertz is here. Let's get it going again. Now the reason for having the SDR even on here is to spot the local oscillator. With this radio, what I've discovered is it issues a lot of signals up close, including the local oscillator. So much so that it's just too much to sort out on the SDR. The SDR is doing its own weird things, and the local oscillator is very strong in this radio. And if I hold my, look at this, this is my pickup coil. It's just a clip lead clipped together, you know, better known as a short circuit. That's my pickup coil for the SDR antenna. And I had it up like this for quite a while. That's what I've done with other radios. I have it about this close. Sometimes I put an actual coil down here to improve its pickup. At this point, there's so much stuff on the SDR you can't even figure out which one's a local oscillator. I wasted a lot of time with that until I learned to take this away about a foot and a half or 2 feet, or maybe just throw it on the bench here. Now the thing about this is, if it's not bolted to the radio somehow, then if I swing the radio slightly, I swing the antenna relationship here, and SDR will vary. It only vary in strength though, it won't vary in frequency. And so I'm going to lock this guy down here. That'll keep it from moving to some degree. No, it won't. Let's try that. Okay. Now, in order to see the results of the test, I have this meter connected to the speaker. So we have to listen a little bit to what's coming out of the radio in order for this meter to show it. So the antenna connection now coming from the signal generator, as I said, is fed through that interface circuit, that frequency sensitive interface circuit. So conceivably, when the radio looks back, it's seeing something like 300, 400 ohms, something of that sort, which is very similar to a long piece of wire. The instructions in the manual say, connect the common lead from your test equipment to this ground terminal here, which is essentially to the chassis. When I do that, I get a tremendous hum on this radio. It wipes everything out. So what I've done is I've connected it to the B- down here. It's just with this clip lead, just down to B-. I can make that connection. It does not introduce a hum at all. The moment I make it, the radio goes much quieter. You know what? I'm not so sure that's true anymore now that I have this interface in here, but it doesn't become noisier, let's put it that way, and it still receives the signal from the signal generator just fine as far as I'm concerned. How important that circuit is to me in what I'm doing in here, I'm not sure it's terribly important in terms of its frequency effect. My problem is if I hook up a wild impedance to this, like a low impedance to this, it's going to throw the local oscillator off. And from then on, I'm misaligning the radio. That's the reason we have the SDR, to keep an eye on the local oscillator. Okay, is that enough talk? Usually I find when I have this much complicated equipment going, everything goes berserk. So we'll see what happens here. Ready to switch on the radio. Okay, there we go. Now watch the SDR while the radio warms up. Remember, radio tuned to 20, SDR looking at 20 on its loop. Let's see if anything shows up. I guarantee if this loop were hanging up in the back of the radio, a forest would rise up on this screen. Now sometimes looking at the waterfall display is helpful in spotting things that are coming and going. So I haven't seen anything. Oh, there's something. There's a couple things. See on the waterfall display? You can see them coming in, they're drifting into their places. Look at them all. There's like 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Everything major on that screen, everything that's drawing a line on the waterfall display is coming out of that radio right now. Or is it? Because I found my SDR really likes putting up what I think are false signals. Now, I'm looking at the video on my monitor. I've got two monitors in here. One of them showed a huge gap in the image of the one you're watching. In I don't know. Okay, something funny happened there with a big gap in the waterfall display. I didn't see that on my version of it, so I don't know what that was. Just add it to the list. Now, I'm going to tune the radio and we're going to find out if that yellow line is really a local oscillator. Here we go. So the way I'm determining what is the real local oscillator, like look at this thing. Look at this deal. See, it's still seeing stuff. I think that's an overload on the SDR. So is that really the local oscillator? And I spent a long time trying to convince myself of what is the local oscillator and what is not. So the radio is tuned around 20. We would expect the local oscillator to be 455 kilohertz above that at 2455. And you see something at 2500. That's pretty much proof positive, isn't it? Or is it? So to prove this out, I know the IF is aligned at 455. I did it. So to prove this out, I'm going to feed into the radio a signal from the signal generator at 455 kilohertz away from where the local oscillator is. So I'm going to set the local oscillator using the SDR to 2455. Okay, so 455. Oops. So the red tuning line is sitting on 455, 2455. I'm going to move the local oscillator to that frequency by just matching it up with the line. Now, if this is all true, if I've got this right, and that really is the local oscillator, if I feed a signal into the radio at 20 megahertz, it will come out the speaker. Now, this is it. This is the moment of truth. Again, you're seeing variations on the SDR display that I am not seeing on my actual computer. So, don't know why it's doing that. Probably some video framing thing or something. Yeah, it's doing it right now. So that carry on, Jim. 20. Ready? There we go. Did you hear it go by? Look at that. So that tells me that at 20.455 there must be a signal in the mixer in order to provide an output with 20 megahertz here. It's like, if you think I'm just killing myself over this, it's because of what I've been through the last couple of days with this radio. So Good. Now we're ready to do the alignment. So look at the radio is virtually on 20. You know what must have happened? It must be that the end of the day yesterday I made some mistake right at the end, and things are actually okay when I thought they weren't, because it's getting pretty much 20 at 20. Oh, so that tone, I think you can hear it, that kind of a low tone, that's just there all the time. There's a mystery as to what that is. So there we are. So I'm not going to get any closer to 20 with this radio. That's more than the width of the pointer, I'm pretty sure. 20. Thumbs up on 20. Now let's ruin this party by going down to 15 and trying it down there. 15. Oh, that pointer has a wiggle in it, doesn't it? That means it's probably rubbing at the bottom there a little bit or something. Okay, so that causes a alignment error. Look at my hand going back and forth, and the pointer's hardly moving. But I think the capacitor is. I mean, you can only expect so much of these radios, right? I'm sure I'm going ridiculously far. What's happening here for me is these are all practice sessions for a big whopper, my favorite radio in the world. It's going to come in here someday and get aligned. I've done it a couple of times in the past, but each time I want to do a better job of it. So I'm winding myself up for a radio with 30 tubes in it. It's a big radio. That's why I'm taking so much time here, to try to just wring out all the stupid out of my head before I go to work on this really big radio. Maybe 6 months from now. I'm not rushing for it. I got lots of other radios to work on here. Okay, so 15. Is this really 15? Is it really 15? Without increasing the output and using this RTMA, they should provide the same signal strength here. And there we are, 14,500. It's 500 kilohertz out at 15 megahertz. That's probably what happened to me yesterday. I think the last thing I did was I checked at 15 and went, oh my god. So a few other things I've learned about this radio is you successively do the bands. Of course, they always give you an order to do things in the manual, so you're not running around crazy. Well, there's a reason for the order. In some radios it's really critical, and this one it is. You start with the high band, you start with the high band here, and you work your way successively back to band 1. And what's happening inside the radio is what you've done with this top band is influencing the next band down. So if you don't bother aligning this, and then you go ahead and align this band, and then you go back and fiddle with this one, it's goodbye to this one, and this one, and this one. Where's my finger on the screen here? So these are all hard-learned lessons here. So what am I supposed to try with this? There's only one oscillator adjustment on this band. The oscillator adjustment is out a little bit more than maybe it would want to be. It's opened a little bit further than you'd want it to be. Along with that comes the RF tuning, which is this slug here. See how I get close to this coil. What to do? So here's my thinking on that. This radio goes up to 30 megahertz. There's nothing going on above 17 anymore these days. It won't be for a couple of years, and there's never much going on up there anyway. The real interest for me in listening to shortwave starts in the 17 megahertz band a little bit, not much. 15, yes, that's interesting. And make this radio work more accurately around 15 megahertz. Particularly, it'd be nice to tune to 15 and hear WWV come out and not have to go hunting for it. So I think I'm going to, I was just going to say, I think I'm going to force the alignment, the oscillator and that to work properly at 15 and hopefully at 17 and forsake everything above it. Anyway, I don't think this radio works well above it anyhow. Even if everything were aligned properly, I don't think it's got very good reception about it. And the problem with that is perhaps that leaves the top band aligned out of the range that would allow the other bands to be aligned. Well, maybe so, Jim. Time to start doing it. How long have we been going here? 10-15 minutes already? Okay, so we want to hear 15 at 15. If we can even get there. First, which way to turn this? So I head in the direction I want to go, up. And now I'll try to find it. Not that way. Oh boy. See, it's never going to make it. Because that's it. The screw's going to fall out of this capacitor here. Okay, so you see I do have the band spread stuck where it is. You know what you'd have to do with this radio? You'd have to make a chart up and use the band spread as a trimmer all the way, all the time. I wonder if that was their thinking with this radio. That they could do kind of a sloppy job on it and just have the operators compensate by doing this all the time. Okay, so which way is it to 15? It's this way. I'm not even going towards 0. Oh my gosh, this won't get us there either. What's happening here is so I think the trimmer capacitor has reached the end of its run. It's doing funny things right at the end. So the next possibility is some of these big mica capacitors, maybe they've gone off. Another possibility is I just forsake band 4 and say forget it. Band 4, forget it. It's just not going to happen. Don't worry about it anymore. Return this to a more neutral or typical position. Like that. I put 15 on that. Okay, that's 15 megahertz on the signal generator. That's 15 there and you can't do anything about it. And return this to where the instructions say it should be. 0. During this process of alignment. With it at 0. Yeah, look at that, over a megahertz out. So, you know, megahertz is a suspicious number. It's dangerously close to 910. 910 is double 455. So let's look on the SDR and find the local oscillator at this point. Let's just I'm going over the same territory again. So we're down around 16. So that would look like the local oscillator there. If we're trying to tune in 16, we expect the oscillator to be 16 plus 455. There should be like 1660. 16600, that's here. That's got to be the local oscillator. Let's just wiggle it. So a local oscillator is currently at 15, roughly 15, 455. The radio's tuning in 15, but it's saying 16. So there is an image on here. There will be an image signal. We're tuning in 15. There'll be an image at, well, oh, just about 16. Let's go see if we can hear it. So that'd be another megahertz above, 910 actually above. Right in here. I don't hear it at all. So if on the other hand, it could be a megahertz below. Watch this. Ha! So where's it now? Where is the okay, which one of those guys is the local oscillator? They all are. Oh my god, here I go. Here we go. So the radio's got 15,000 stuck into it. If the local oscillator is below, then it's at 14, 5 something, 14 something, 14, 5 something would be this one. Oh my gosh, how am I going to tell this out? First, it has to go in the same direction as the tuning. It does. Since we're giving it a 15, just under 15 megahertz signal, it has to be 455 away. 455 away from 15 going down. I'm losing my mind here. 14, 4, oh I can't calculate it. You know what? I really just I'm guessing this is happening to everybody right now. If you try to concentrate on anything you can, because my thoughts are constantly flipping to what I have to do later today, which is make a trip to another city and risk my life. For just calm yourself down, Jim. Start over. It says 1500 on the dial. It doesn't really matter. 1500 signal being sent to it. The weak signal picked up there. It has to be 455 above or below it. If it's above, then it's at 15,455. 15,455 is right in this area. I don't see a thing. If it's below it, I can't calculate anymore because for some reason I'm losing it here. So I'll use a calculator. So 15,000 minus 455. 14,545. Thank you. 14. So 14,545. There it is. So this is the local oscillator. It's below. Right now. The local oscillator is below. Ah, my mind's blown.
Gotta stop.
Okay, I'm ready to go back at it here and calm myself down a little bit. Oh my gosh. What a world we're in now. So I'm going to do band 3. I've already switched this on to band 3. And we will start by looking in the manual and seeing what it says about this. So this is the top band I'm giving up on. Step 3, 14 megacycles. That's top of the band again. H and J. H and J. H is the middle one. J is the bottom one. H, J. Okay. That's a cat knocking at my door. Okay, because my cats keep me calm and maybe they help you too, let's have them come in. Peanut, come on in. Yeah, come on. Come on. No. Peanut, I just... No, I'm not. No. Sorry, buddy. Yeah, being a little rude with him. I was just sitting with him for the last while. Why would he want me to sit with him some more? Okay, back to what we're doing now that I'm totally up to lunch here. 14. Watch that SDR. There's 14. Interesting, the reception went up and down and up. The noise level went up and down and up. In previous experiments not posted, with a scope hooked up to these antenna terminals, I could see a frequency, probably the local oscillator, strength going up and down, and the radio responding with that noise level going up and down in conjunction. It's just another big question mark about, oh, what is happening there? So, not exploring that at this point. I'm having a hard enough time just doing the alignment stuff. So we're dialed up on 14. Should get the SDR into the right range. Oh, it is. We should see a local oscillator here somewhere. See if we can spot it. Okay, so I think I see it. Oh, peanut. I think the local oscillator is right here. That guy. Let's put him at 14,455. Oh, peanut, please, really? Yeah, maybe he wants to go out in the garage. Peanut, can you wait 1 minute? I'm just going to check this. If I leave now and come back, I won't remember what I was doing. So, if we put the local oscillator now right on the line, this radio should be ready to receive 14 megahertz. Why would that not work? Not enough? What? How come that didn't work? Did I not switch the band? Maybe I switched it and switched it back. No, that's band. We're in band 3. And the dial is 14. Yeah, wait, peanut, things are going awry here. Oh my gosh, really? Oh, smokes. Okay, I'm going to go sit with my cat, because I can tell you right now, I probably can't push the local oscillator to make this radio receive 14 when it's dialed up to 14. And I think moving the band spread will make it even worse. There's something generally amiss with this radio, I think. Peanut, where are you? Where'd you go? Okay, let's see what's going on at the other end of the band. Now I've tuned it down to 6 megahertz. Let's put the SDR down at 6 megahertz too. Okay, so this is probably the local oscillator here. Let's turn the radio tune down. Good, it's moving the right way, and it's pretty strong there. So I'm quite certain that's the local oscillator frequency. So put back right on 6. It is on 6. With that on 6, the local oscillator should be at 6. It should be, well, I'll put the red line where it should be. Whoops. It should be over here. 6.3, 6.5, 200 kilohertz. I can probably get it there. Let's see if we can do that. Move the local oscillator over. Wrong way. Look at that. It's not going to get there. That's the end of the travel. Okay, let me close this in a little bit. If I use the band spread. Band spread can get it there. Band spread on 40. So I put the band here. Let's go back to 50. Put the band spread on 50. Now I think I can get it there. I've traveled down this road so many times. And you're watching this on the video. Okay, so now the local oscillator is operating at 455, and we should have 6 megahertz tuned in on here. Bingo, right on. So on this band, at this frequency, with this oscillator setting and with that band spread setting, the radio is accurate. Now is it accurate up at the other end? There's that hiss going up and down again. Let's try it at 12. Okay, 12. .400 kilohertz out. There's the image. It looks like there's just no way to make this thing work properly. That's what it looks like. Now, because of the way the radio works across the band, the low end and the high end, when you're fiddling with these capacitors, I think you're doing this. The high end is changing a lot, and the low end isn't changing nearly as much. So it's possible that you go out to the high end and you force it to where you want, and the low end is actually not moving that much. But I know from experience, having done this a number of times with this radio, if I go ahead and do that, if I make this thing tune properly at 12, it will be far out at 6. It will be out quite a bit. So something is happening here that's causing all the two bands I've experimented with thoroughly to tune at one end or the other, but never both. And if you tune it at the low end, the high end you're tuning frequencies lower than what the dial is telling you. And in order to pull that up, you have to reduce the amount of capacitance in the trimmers. The reduction is limited. There's only so much in a trimmer. Can't get it there. To reduce the capacitance. So just, this isn't necessarily 100% true, but that would make you think, well, if one of these capacitors is weak, I don't know what weak even means with a capacitor like this. If its capacitance is less, then we have to find that one and replace it with one that has more capacitance. How does the capacitance in these big brown capacitors change? They can become leaky, but these aren't even likely to become leaky. They can short. I've seen these kinds of capacitors short. It's a kind of unexpected thing. And I suppose they can have lead failure, where the capacitor leads no longer actually connecting to the plates in the capacitor. It's another form of failure. Not enough capacitance. Is that true? What does it even matter at this point? What am I going to do about that? What can I do about that? This is a pretty weird arrangement right here. This capacitor is just floating out here, way up in space. It's got a resistor connected to it, just floating out here. I think it's factory. Is this guy in a very, very, very particular place? Is that an adjustment right there? Let's get the, I have no idea what it's doing. Let's get the local oscillator visible here on the screen. So we're fooling around 12. We'll go up around 12. We'll do this up around 12. We'll move some parts around. Local oscillator is probably this guy here. I'm going to move him more central on the screen. We'll verify tuning down. Yep, in the right direction. Big strong signal, 12 megahertz, and we're tuned around 12. That's got to be the local oscillator. It should be. It should be with the radio tuned to 12. This guy should be he should be up in this area. Okay, so I can move stuff around now. You want to watch the waterfall display. It's really obvious if the first, as soon as I bring my hand near, it's going to throw it off. Look at that. Look at how far it moves. Tell me the position of this capacitor isn't important. Now, can I get at it without affecting anything? Can I get onto it? Okay. This is just a wild idea here. I don't have any reason to think this is really effective. Let's move it. Let's see if I can move it. Move it. Oh, I almost shorted it out. It certainly affects it. What would we want to have happen here? What would I want to have happen to that local oscillator? It's I want to add capacitance. I'm moving this capacitor in space. This must have been a known fact. Good grief, did they really do that as an adjustment? I can't believe it. Let's move it a fair bit. Can I go this way without shorting anything? Quite a distance. So, I mean, it's not dramatic. It's not dramatic enough that I can consider this to be a helpful adjustment. If it jumped across, I'd be a little more excited about that. What about this resistor here? I'm really taking a shot in the dark now, doing stuff like this. There's a coil here right near the thing. So I'm looking for something with super sensitivity here. So that's just a little wire back here I'm moving. Okay, it's not flying, it's got to go flying. I'm doing this on band. It would depend upon which band you're on, I would think. Let's just flip up to the... Oh, I have to find a local oscillator if I do that. Okay, we'll go up to the top band. Now we're tuned to 28. I want to get it below 25. We'll go to 22. 22, we'll look for the local oscillator here. 22, 455, that's where it should be. This is probably yet out here. A wiggle, down, yep, went down, that's got to be it. Too low on one band, too high on the other. Sensitivity. We've already seen the sensitivity not that great on band 3, but let's just fool around here a little bit. For a real dramatic movement here. No. It's not going to happen. Nothing is this sensitive. How about this capacitor I put in over here? I didn't exactly do it. You just get little tiny movements. This whole thing. Now I'm looking for something to go shooting back and forth. How about down here? Any chance? Anybody? Ooh, what was that? That'll get a little bit of movement there. This is such a long shot. And you have to think that they built this radio and it made it out of the factory properly tuned. And just going crazy. Ooh. Okay, my hand can be affecting this. There's another frequency moving around in there. This one here. This one's moving around too. Get into which one's the real local oscillator game here. No, I know the real local oscillator has to go down at this point. I'm tuning down. It can't go up. So that's an artifact of the SDR. The one on the left I was curious about. There's one coming in there on the left, on the right. Okay, so which one of those are real? So can you see the one on the right moves at twice the pace? And it will go right by. Right by. It's the one that's painting the line. That's the real local oscillator. Where am I getting with this? I'm just drawing more and more conclusively that you just can't align this guy. We just can't get him even really decently close. So if we accept that's the case, you can't get the dial accurate on this radio, no matter what. We set it as close as possible to the most important parts of the band and try to continue with the front end alignment to match whatever the oscillators come out at. We set all these roughly where they are, roughly in the middle of their range, except whatever the heck happens, and attempt to tune the radio with the other. I don't know what else to do. Band 4 in the middle, at 20. We'll send them a 20. $19.4. Okay. We'll tune it in maximum on the meter here. And now we'll try to peak that up. This one goes with this one. In the middle of the band. Oh, this one doesn't go with this one. This one, Jim, this one goes with this one. This one goes with this one. Hope I got this right. Yeah. So you can even tell this is shifting the local oscillator, I think. Oh yeah. I think that's it for that. You won't check it, move on to the next band. Do exactly the same thing. Look in the middle, what do we actually tune to? 8, let's put it right on 8. Whatever comes out here comes out. 8, find 8 here. It's pretty darn close, isn't it? Let's just see if we can get it to 8. I'm just itchy to make this thing work. 8. Okay, look. It's receiving 8 at 8. Now we do the tune-up, which is this one. Open her up wide. Okay, that's it for that band. See how fast this can go when you just don't really try hard. When you just say, you know what, whatever happens, happens. Maybe a fatalistic attitude is what's appropriate considering the world today. Okay, so 3 is a tough one. 3 is right at the end of this. That's right on the money. Okay, tune it for maximum here. Okay, now some control here has to be adjusted. Let me look on the manual quickly. See what it is. Supposed to be doing this at 5. Doing it, so we're doing it in the middle. K and L. K and L. Middle of the top one. K. Okay. Okay, K. K is the oscillator. It's okay. We think it's okay. So all I want to do is the other one. K and J. No. K and L. L in the middle. See, I did all this once before, twice before. So these ones, at least in the middle. Come on, stop camming out there. Again, it wants to be open a lot. Okay, and last band. Last band standing. Band 1. This one's pretty important. Let's see what we can do with this. So band 1, if we look at the actual instructions for band 1. 1500, M and N for maximum output. M and N. M, so 2 N's. M, N. So we'll try this. 1500. We'll actually try this on this band. This band might work quite differently from the shortwave bands. 1500. High, so we'll try to bring it down, end and end. What's this one for? Wants to be open again. They all want to be open. So I tighten them up a little bit. Okay, and now the other end, 600 kilocycles. P is probably that one I just asked about. P, yes, P is this one. P is the other end of the band. This is only effective in AM probably. We'll go to the other end of the band. You know, when you do these radios, you just never know where you're going to end up. What's going to be the challenge. I'm doing this whole thing with the band spread at 50. So, I mean, that's an error in terms of the procedure. I'm sticking with my error at this point. 600, can we do it? Pretty close. 600, this guy. Oh, it's tight. It's tighter. Okay, that's good. That's 600 at 600. Yeah. $900. So just a little high, but you know what? If we put this at 900. And then we tune the radio in. I mean, yeah, it's a hair low, isn't it? Okay. Let's go up to. Let's try 1500. Okay, 1500. Now there's parallax in the camera view, but I'm avoiding that. That's 1500. 2300. So I think that's double the IF frequency there. That's the image. Is that possible? That's not possible. Is that? Pretty darn good. Is that the end of the road? That's the end of the road, isn't it? P for maximum. At 600. P for maximum at 600. Oh my god, let's check this radio out and see what we've ended up with here. Is this a radio or is this a big failure? I want to remove this. And we want to remove this from here. Now we want to put a real McCoy antenna on it. Here comes the real McCoy. Turn the volume down here. This goes to a wire antenna in my backyard. A wire antenna that some time ago, a few videos ago, I showed a quick clip of some guy working in my backyard, tree trimmers from the power company. They cut down one of my antennas. I went out there and I told him, you see that wire? Don't worry about that wire. That wire's just an antenna. And I can't imagine why they cut it. So I kind of threw it in the trees there yesterday or the day before. Still lots of wire on it. Should flip it down so we can see it normally. Let's do that. Danger, Jim. Okay. Yeah, a little hard to see it normally there. Okay, Mr. Radio, let's do your thing. Just trying to get the meter in view here. There we go.
Parlons des bilans, des chiffres, parce qu'eux parlent froidement de la réalité de la pandémie. Voilà, au Canada, la courbe de progression du nombre de personnes qui sont atteintes de la Covid-19 montre que ce chiffre, que ce nombre double tous les...
$680. So this signal has a noise signal right beside it. So if a radio can distinguish this enough that you can listen to it, it's not bad. Some radios can't do it.
And clients and everyone saying, why? And you're saying, listen, one, if you look at the exchange rate, gold is only off really $100 from its recent highs. It's still positive in Canadian dollars. Silver's definitely down.
I have to check my gold stocks, I guess. $590. Well, it's nothing to get too excited over, but it's working, and the stations are in the right spot. Now let's just go up band by band. We shouldn't get anything really on this. Maybe out here. You can see the pointer is wiggling there. It's dragging somewhere behind the paper that the dial's on. The paper is wobbled. So that's what's happening there, I think. We shouldn't get anything on this band. Just noises. Local noises from my house. Okay, but I'd say that sounded normal. Okay, now we're on the 14 to 5. This one, we might get some stuff. Excellent. Ham radio. Excellent. Wow, lots of it. Okay, let's try the BFO. There's a guy talking there. Okay, so clearly, in terms of clarifying a voice, the BFO in this radio, or whatever you want to call it, the technique used in this radio is crap. Let's see if we can get some Morse code here. Somebody talking again. So every signal I pick up now that has a carrier will produce that heterodyne. No Morse code. Surprising. For all those voices and okay. Carry on. So this band is a European shortwave band, and occasionally you can pick stuff up in it. The target is Europe, so picking it up in North America is tricky. Oh, get this off. I don't want that on anymore. I notice the radio is not stone silent like it was. There's a noise level to it now. That's probably the effect of the alignment stuff I did.
Which is worse, expecting the rapture anymore or not expecting it at all? John Fletcher once wrote a letter to John.
Guy's got coronavirus.
The right attitude toward expecting.
Brother Stare.
The sword is
There we are.
the spirit. That's right. Hebrews 4. For the word of Yah is living and powerful and sharper
There
than
we
any
go.
two-edged
Now we got a
sword,
good signal.
piercing even to the division of soul and spirit and of joint, and is a discerning thought, intents of the heart. It's right there, to overcoming. As Satan lures to sin,
This seems like it just won't quite.
Scripture committed to memory become a sword in our hand to
Yeah.
slay the
Tough to
temptation,
tune.
because we see that the beauty and love of Yahweh are far greater than anything the world has to offer. That's very true. You're inspiring me to go and commit.
Do you know all the names of God? Yahweh? Do you know God in the Bible talks about other gods? Thou shalt have no other gods before me. And more than that. There's other gods?
2 Peter 3 verse 12.
Wow. That's American religious broadcasting.
The will is weakened, and right then is when the devil comes to tempt him. How did the Savior, in the hour of temptation, triumph?
by quoting.
I just got to ask that question again. Why didn't Jesus, when he was on the planet, tell people about bacteria and maybe even about viruses? Why didn't he tell people? Think of all the lives that would have been improved. Was he just callous about it? He just didn't want to tell you? Yeah, figure it out for yourself while I busily do a bunch of miracles. Ah, a little bit of a cynical attitude from me, eh? Okay. So we're down so low now, I don't think we're going to pick up any international broadcasting stations this time of day. No. No use even trying the upper band. Okay, so what's that say? Is this radio finished? Is that the end of it right there? All done? Maybe one last thing is when maybe this evening I'll listen to it and just check it out. I just don't think I can wring more out of this radio. I think I beat it up as much as I can. It has beaten me up an awful lot too. Funny little radio. Okay, that's it. I think that's it for that radio. I think that's it. Yes, that's it. Thanks a lot for watching. Sorry about how sloppy the whole story got with this radio. My videos maybe not being as clear a story on it. If you've got one of these radios and you're going to try to tune it up, my guess is you're going to run into all the same things I just ran into. So good luck with that, and I'm going to dig out another radio, one that won't spin me around in circles.